Good morning viewers, welcome to my YouTube videos in High Physics Vlogs.
Hello, good morning students. Today I would like to discuss vectors and its basics in a easiest way to understand this. First of all, you have to know the difference between what is a vector and what is a scalar. So go for the scalar. So first scalar. What do you mean by the scalar? A physical quantity which will having only magnitude but no direction is called a scalar. That is the definition of a scalar. That means a physical quantity having only magnitude but no direction is called a scalar physical quantity. So what are the examples for this will be, example number 1 is distance is a scalar, some more work is a scalar, some more speed is a scalar, etc. This is the example for the scalar physical quantity. Next, go for the vector. How will you define a vector? Vector means a physical quantity which will having both magnitude and direction is called a vector. So how can write a physical quantity having both magnitude and direction is called a vector. So the examples for the vector is displacement is the best example. Some more you can write velocity and torque, etc. These are the examples for the vector. Now how can you represent a vector? Say for example, a person is here, he is moving from this point to this point, that means A to B. If you say the length itself indicates the magnitude, that means AB, which we can call as a scalar. That means here there is no direction. The person is moving from A to B or B to A, we don't know. So if a person is moving from A to B like this, represented with the arrow mark, then we can say a vector can be represented like this, vector. That means AB arrow mark, put a AB bar. You can say that this is a vector physical quantity. So this is the difference between scalar and a vector. Now, if you want to know the position of an object, that can be explained in 2-dimensional and 3-dimensional also. Say for example, if you go for the 2-dimensional, so 2-dimensional, that is 2D. Say for example, 2-dimensional means it will having two axes. One is x-axis, another is y-axis. So this is the origin, you can say. Say if the person is moving along the x-axis in this direction, let us say at a distance of small x. Now this direction, that is nothing but unit vector represented with the symbol of I bar on the x-axis. Say if the person is moving on the y-axis, let us say, that means it is moving here to here. So it travels a vertical distance, we can say small y. Now this can be represented with the unit vector direction, that is j bar. That means if the person is moving in between this 2-dimensional plane like this at this point, let us say, so this is point where this person moving in xy plane. This will be represented with the coordinate system x comma y. If it is the P point, then we can represent OP bar, that is a vector representation will be like this, xi bar plus yj bar, like this. If the person is moving in the 3-dimensional plane, let us assume if your room will be in the cuboid, your room will be in the cuboid shape generally. See, at this point, let us say this is x-axis, this is y-axis, and vertical will be the z-axis. Here is the horizon. If the person is moving like this in the x direction, this is in the y direction, this is in the z direction, let us say. So if it is like this, okay, no problem. Now, not y direction, this is z direction, you can say. Say if it is moving in the x direction, we can say that at this point x. If it is moving in the y direction, we can say that this is the point y. If it is moving in the z direction, you can say that z distance. Now x can be represented with the I bar, y can be represented with the j bar, z can be represented with the k bar. Now if the person is here at this point, say again P point, this is the origin O. Now the distance traveled from O to P in the three-dimensional plane, the coordinates can be represented with x comma y comma z. This is in the three-dimensional plane, 3D. Say this OP bar can be represented like this. OP bar is equal to, you can say, xi bar plus yj bar plus zk bar. Now if you want to determine the magnitude of this OP bar, so magnitude for this OP bar mod, which is equal to under root of x square plus y square. This is for two coordinate system. For this three coordinate system can represent the magnitude OP mod is equal to under root of x square plus y square plus z square. This way you can represent. Now this dot products, some more about this one is of a vector. How can you resolve a vector into the two components? For this explanation, here I am taking a ball which is thrown into the air, making an angle theta with the horizontal. This is the theta angle, this is the horizontal. Now if you want to know at this point the direction of velocity, always tangential direction. Say this is the velocity v bar. Now this v bar can be resolved into two components. One is vx, this is the horizontal component. Another is vertical component, that is vy. How can you resolve this into two components? So these two are, so this is the x direction, you can say x. This is the vertical direction, say y. At this point, now from this will be, if you extend this, it will be looking like a right angle triangle. I am drawing this right angle triangle here. This is v bar, this is vx, these two are parallel, that means we can say this is vy, which will make an angle theta here. Now from this right angle triangle, as we know that sine theta is equal to opposite side by hypotenuse. The formula is opposite side by hypotenuse. That means opposite side is vy, hypotenuse is v. That means from this, by doing the cross multiplication, you will get vy is equal to v sine theta. That means vertical component here I will get is vy is nothing but this is vertical component is v sine theta. Similarly, you can use the formula cos theta. Cos theta is nothing but adjacent side by hypotenuse. That means adjacent side for this will be vx, hypotenuse as usual v. That is vx by v. From this you can get vx is equal to, do the cross multiplication, v cos theta. This you can say the horizontal component. So here you can get horizontal component, that is vx is equal to v cos theta, whereas vertical component vy is equal to v sin theta. Say if the question will be like this, if a horizontal component and vertical component are equal, then what is the angle of projection? So if a horizontal component component is equal to vertical component. Then what is the angle of projection? Theta is equal to how much? That is the question. That means we can equate these two. That is V cos theta is equal to V sin theta. That means V gets cancelled. Sin theta cos theta. That simply can write sin theta by cos theta is equal to 1, which is tan theta is equal to 1, which is equal to tan 45 degrees. That means angle of projection is 45 degrees. Or simply you can say pi by 4. So in this way we will get this. So this is very useful for work done and torque concept, linear momentum concept. So these are useful for this one. Now in this dot product, we go for the dot product. Next item will be dot product. So how can you define the dot product? Say if A bar and B bar are the two vectors, then their dot product is equal to, now dot product. Dot product means if two vectors A bar and B bar, let us consider, their dot product is equal to product of their magnitudes and cosine of the angle between them. That is the statement of dot product. Say if A bar and B bar are two vectors, then their dot product is equal to product of their magnitudes and cosine of angle between them. That means you can write it mathematically. A bar dot B bar is equal to mod A bar mod B bar cos theta. Or simply you can write A bar dot B bar is equal to AB cos theta. This is the final formula for this. Now you can write the properties also. So among them, one of the some important properties, if theta is equal to 0, we can say A bar dot B bar is equal to simply AB. Why? Because cos 0 is equal to 1. If theta is equal to 90 degrees, that means cos 90 is equal to 0. That means A bar dot B bar is equal to 0. Means A bar is perpendicular to B bar. You can write like this. Some more important things. This is important. Remember this. What are doing the problems? It is important. Some more about this is, if I bar, J bar and K bar are the two unit vectors in the directions of X and Y and Z axis, then we can say that I bar dot I bar is equal to J bar dot J bar is equal to K bar dot K bar is equal to 1. This is very important. Remaining I bar dot J bar is equal to J bar dot K bar is equal to K bar dot I bar is equal to 0. This is very important thing. That means now example for this dot product is the easiest example is work done. Work done is the best example for the dot product. That means what is work done? Okay, how will you define the work? So simply you can say mathematically the product of force and displacement is nothing but work. So you can say product of force and displacement is called work. Or simply you can explain for this. Let us say this is the horizontal surface. Now if you put a block here whose mass is small m, now if you pull the block here in this direction, F force is applied, which will make an angle theta. Then the block will move from here to here. Mass will be same only. It will travel a displacement of S displacement. Now we can say that what is the work done here? Now here, this is the F force in this direction making an angle theta with the horizontal. This F can be resolved into two components. As you know that this is the horizontal component, that is F cos theta. Now the object will move in the linear only. Here applying the force will be with some angle. Then we can say that the work done according to this one, work is equal to, you can say that product of displacement and horizontal force, horizontal component of force. That is product of horizontal component of force and displacement. So we can write it mathematically. W is equal to, that is horizontal force is F cos theta and the force is S. Now from this I can write simply Fs cos theta. As we know that according to the dot product, A bar dot B bar is equal to AB cos theta. That means we can write W is equal to F bar dot S bar. This is the formula for the work done in terms of vector notation. Here if theta is equal to 0, we can say, if theta is equal to 0, we can say work is simply Fs. That means force is also in the horizontal direction. We can say this one. If theta is equal to 90, then we can say that work done is 0. This is about the work concept. Okay. Now, how can you write some more about this work? Units of work. Units will be generally joules, and this is in the SI system, whereas ergs in CGS system. As we know that 1 joule is equal to 10 power 7 ergs. This is the unit of work. Okay. Next, for this we can do some example problems. Say if force F bar is equal to 3i plus 2j plus 4k bar and displacement S bar is equal to 2i plus 6j plus 3k bar, let us say. Now find work done. So as we know the formula, work done is equal to F bar dot S bar, dot product. That means you can do this like this solution. Now W is equal to 3i plus 2j plus 4k bar dot 2i plus 6j plus 3k bar. As we know the properties in the dot product, I dot I, j dot j, k dot k, we should be 1. Remaining terms I, j, j, k, k, I all are 0. That means simply you can write W is equal to 3 into 2 plus 2 into 6 plus 4 into 3. That means remaining I dot I, j dot j, k dot k will be 1 only. Remaining 0 means no need to use that one. Simply coefficients multiplication, that is equal to 6 plus 12 plus 12, that is nothing but 30 joules. The formula for the work, the value of work done is equal to how much? 30 joules. From this I can get that simply in dot product, two vectors dot product is a scalar. Okay, this is very important point. You have to remember this. This is one example. So example 2, example 3. So remaining examples you can do as a homework. Similarly, example number 2, if a bar is equal to 6i plus 2j plus 3k and b bar is equal to 2i plus j minus nk bar. If a bar is perpendicular to b bar, find the value of n. If the question will be asking like this, a bar is equal to b bar is equal to, if a bar and b bar perpendicular, then find the value of n. That means as we know that if these are perpendicular means condition is a bar dot b bar is equal to 0. That means do the cross multiplication dot product, that is a bar dot b bar is equal to 6i plus 2j plus 3k.
Hi sir.
Hi ma.
Wanna?
Now that is 2i plus j minus nk. Dot product simply equating to 0. That means 6 into 2 plus 2 into 1 minus 3 into n is equal to 0. Then 12 plus 2, that is 14. 14 minus 3n is equal to 0, or n is equal to, you can say, 14 by 3. Simply the value of n will be 14 by 3. In this way you can use the work done example of the dot product. Okay, remaining topic will be covered in the next video. Thank you for watching.